Welcome to Lecture 14, 3.5, the 5-number summary and box plots. So, for Objective 1, computing the 5-number summary. Alright, so one thing to remember is that the median is a measure. Let me change into a pen real quick. It's the measure of central tendency that divides the lower 50% of data from the upper 50% of data. So remember, just think about the bell curve. If we have the median, it's splitting it right in half. So you have 50% of the data and then 50% of the data. Okay. It is resistant to extreme values. And it's the preferred method of central tendency when the data are skewed right or left. Range, standard deviation, and variance are skewed. It's not skewed. Range, standard deviation, and variance are not resistant to extreme values. However, the interquartile range, which is q sub 3 minus q sub 1, the difference between the 75th and the 25th percentile is resistant. So the 5-number summary. What you look at for the 5-number summary is the minimum, first quartile, median, third, and the maximum. Right, and this is found on page 158. So let's take a look at the first example. The data shown in the table to the right has the finishing times in minutes of men in the 60 to 64-year-old age group in a 5-kilometer race. Determine the 5-number summary for the given set of data. Alright, so what we want to do is, in order to find the 5-number summary, we need to arrange the data in ascending order. So arranging it in ascending order. Let's see. It's going to be 19.95, then 23.25, 23.32, 25.55, 25.83, 26.28, 28.58, 28.72, and then after that, 30.18, 30.35, 30.95. So remember, we're writing in ascending order. After that, 32.13, 33.23, 33.53, 36.68, 68, 37.05, 37.43. It's a really cold night, so my hand isn't writing quite as well. Okay, 43, 41.42, 42.47, almost done, 49.17, and 54.63. Alright, so the smallest number is going to be the first part of our 5-number summary. So let me write this out. The 5-number summary so the first one is the minimum. That's the smallest number right there. So the minimum is 19.95. Then we're just going to do a comma. Now we need to find Q1. So Q1 is going to be the median of the bottom half of the data. So how much data do we have? Well, we have 21 data items. So we got 3 by 7. So half of 21, or the median, actually right now it'd probably be easier to find the median. So the median is going to be the 11th number. Let's count that out. 11th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alrighty. 30.95 is my median. It was easier to just find that one first. So we'll find Q1 in a sec. So median was 30.95. Okay, so then actually it's also easier to find my maximum. Let me write this down. Minimum maximum. So the maximum is going to be the greatest number. That'll be the 54.63. Now to find our 25% and 75%, or Q1 and Q3. So Q1 is going to be the median of the lower half. So the lower half numbers are going to be from 19.95 up to 30.35. Now there are actually 10 numbers in there. So in order to find Q1, since there's no one number in the middle, we're going to have to take the two middle numbers and take the average. So 1, 2, 3, 4, 5, and these guys. So we're going to use those two, add them together, and divide by 2 to find Q1. And that we can round out to 26.06. Now to find Q3, which is going to be the median of the upper half. Okay, so the median of these numbers. Once again, there is no actual middle number, so we'll have to take the average between the two middlest numbers, so 1, 2, 3, 4, 5, and 6 right here. Add those two up and divide by 2. Let's see what we get. 37.05 plus 37.43 divided by 2 is 37.24. And there we have our 5-number summary. We should box that off. Okay. So it really helps if you list it out. I'm struggling with my box there. All right, and you can read page 158 in the book to find out how to find the 5-number summary using technology, or you can email me to ask. Now let's take a look at the second objective. Draw and interpret box plots. So the 5-number summary is useful in creating a graph called the box plot. Or you could just write box plot. So what are the steps for drawing a box plot? So the first step, you're going to determine the upper and lower fence. And lower fence. Those are, lower fence is Q1 minus 1.5 in the interquartile range. And then for the upper fence, it's going to be pretty much the same thing, but you're adding to get the upper one in the IQR, where the IQR is Q3 minus Q1. Step 2. Draw a number line. Long enough to include the maximum and minimum values. Insert vertical lines at Q1, median, and Q3. And close in a box. Step 3. Label the lower and upper fences. Step 4. This one's a bit long. So draw a line from Q1 to the smallest data value. That is larger than the lower fence, which I'll call LF. Then, once again, very similarly, draw a line from Q3 to the largest data value that is smaller than the upper fence. I'll shortcut to UF. These lines are called whiskers. Probably seen these graphs before. Step 5. Any data values that are less than the lower fence or greater than the upper fence, I'll use UF, are outliers. Oops, that's spelt wrong. Outliers. And are marked with an asterisk. Alrighty, there we go. We have the steps. Now let's take use of it. So we're going to use the results from example 1 to construct a box plot of the finishing times of the men in the 60 to 64-year-old age group. So let me go ahead and write down the information we had again. We had 19.95, 26.06, 30.95, 37.24, and 54.63. Which we had was the min, max, Q1, median, and Q3. Okay, so following the steps, let's see. Well, the first step, we need to determine the lower and upper fence. I'll do that. Let's see. Lower fence is going to be my Q1 minus 1.5 times the IQR. So we actually need to find the IQR. So the IQR is going to be Q3 minus Q1, which would be 37.24 minus 26.06, which gives us 11.18. Okay, we can plug that in. So we have the Q1. That's Q1 is 26.06 minus 1.5 times 11.18. That simplifies that to 9.29. Now let me go ahead and find, I didn't have a lot of room here, but we're going to find the upper fence. Let me just label these. Always make sure to box and label these things, especially when everything's getting messy. So we have the Q3 plus 1.5 times my IQR. And Q3 was 37.24 plus 1.5 times the 11.18, which multiplying that out is going to be 54.01 is my upper fence. Now the next step is to draw a vertical line long enough to include the maximum and minimum. So our max and min, well, we know we need to include 9.29 and 54.01, and we also have a value that's in the 60s from our data graph. So I'm going to go ahead and just, for safekeeping, go from 0 to 60. So 0, 10, 20, 30, 40, 50, and 60. Now what do we need to do? Insert vertical lines at Q1, M, and Q3. Alright, let's do that. Q1 is about 26.06, so a little more than halfway. It's Q1. And then our median is 30.95, so a little bigger than 30. Actually, maybe I'll label those at the top. And lastly, Q3, which is a little less than 40, a little more than 30. I'll go ahead and plot it almost at 40. It's a rough graph. Q3. Alright, next. We're going to enclose these in a enclose it in a box. Here we go. Choop, choop. And normally the box is floating up. And I'll just draw the line for my median. That's not the nicest looking box, but I'll let it pass. Okay. Next step. Label the lower and upper fences. Alright, so our lower fence is about 9.29, so a little less than 10. And that's my lower fence. And my upper fence is 50.01. 54.01. A little bit at halfway. And my upper fence. Okay, so make sure the way I'm labeling all this is how you should show your work as well in case this shows up on an exam. And what else do we need to do? So we're going to draw a line from the smallest data value that is larger than 2.929 and a horizontal line from Q3 to the value that is the largest data value less than 54.01. So those values are, the smallest one that's closest is 19.95. And the other one is 49.17. Okay, and then from these values, we're going to go ahead and draw in our vertical lines for the whiskers. Oops, that didn't quite connect. And lastly, we're going to plot any outliers. So what outliers do we have? Well, 54.63 from our graph is going to be an outlier. So we're going to remove, and we're going to plot that asterisk, 54.63. It's a little bit about here, and there we go. The asterisk for the outlier. Okay, so we've gone ahead and graphed a box plot. Let's move on to the next example, using a box plot and quartiles to describe the shape of a distribution. Alright, so this one's just going to be a few different ideas that you might have. So for example, if we have, I'm going to go ahead and just draw 3, and these are in the textbook if you want to take a look at them better, because I'm not going to be able to draw them that well. So let's say you have one, that these are what the values kind of look like. So it's skewed right. If it's skewed right, what our box plot is going to end up looking like is it's also going to be skewed a little bit. We'll end up having our median about here, our quartile there, our max all the way out here, and our min about there. That's a little off. I'll bring this in. Okay. And the other one we might have is going to be skewed right. Sorry. This is skewed left. Sorry, this is skewed right. Skewed right. I forgot to write that down. The next one we have is skewed left, which is when the data tends to trickle off to the left. And for this one, our box plot is going to be a little more to the right and funnel off to the left. And lastly, for the symmetric distribution, it will look, I guess, as your normal bell-shaped curve. Once again, just a quick graph drawing. This one will look a lot better. I wrote the symmetric too high. This one will look like a nice balanced box plot right in the middle. So just an idea of using box plot and quartiles to describe the shape of a distribution. Now for example 4. So in the Space Lab Life Sciences 2, led by Paul X. Callahan, 14 male rats were sent to space. The red blood cells in milliliters of the rats was determined when they returned. A control group of the 14 male rats was held under the same conditions, and their red blood cell mass was also measured when the space rats returned. The data is in the table below. Construct side-by-side box plots for the red blood cell mass for the flight group and the control group. Does it appear that the space flight affected the red blood cell mass? Okay. So, if you wanted to do this with technology, you could use StatCrunch or your calculator. But we're going to go ahead and do this by hand, since that's how I want you to show it on the exam. So for flight rats, let's go ahead and list out the data in ascending order. I'm going to go ahead and pause the video and write that out. Alright, so I have all of the data written out in ascending power, or ascending orders. So now we need to find our minimum, max, median, Q1, and a Q3 for each of these. So min, Q1, max, Q3, and, max, that was median. Alright, easiest as usual is to find min and max for each one. Go ahead and do that. Min and max. 6.39, 9.79. Find min and max for the other one. Oops, wrong pen. Min and max. So 6.99. 9.94. And then finding the median. So how many items do we have in each? We have 14 items. So finding the median, you're going to have to take the two middle ones and divide. So 14, that's going to be the 7 and 8. Let's see, 1, 2, 3, 4, 5, 6, 7, and 8 for our median. And the other one, 1, 2, 3, 4, 5, 6, 7, 8. That should leave the same amount on either side. Let's check. 1, 2, 3, 4, 5, 6 numbers on that side. 1, 2, 3, 4, 5, 6 numbers on this side. Let's check the other one. 1, 2, 3, 4, 5, 6 on this side, and 1, 2, 3, 4, 5, 6 on the other. Great. Okay, so add up each of these values and divide by 2 to get your median. For the first one, for the median, I get 7.72. I'll round it to, and the next one I get 8.55 plus 8.58. Divide by 2, 8.565. Now to find the first quartile, so it's going to be the middle number. We have 1, 2, 3, 4, 5, 6 numbers on each side, so once again, we're going to have to find a median value here. So adding those up, 6.87 plus 7 divided by 2. Round that off to 6.93. And then for the Q3, 75%. Find the two middle ones, add and divide by 3. 8.64 plus 8.80 divided by 2, 8.72. Let's do the same for the other one. Okay, so middle values, add them up, divide by 2. 7.39, I'll round 2. And then middle of the other ones. That'll be this and that. So 9.14 plus 9.66 divided by 2, 9.4. Alright, so we have all of our values. Let's go ahead and create side-by-side box plots for these two. Alright, so to make it so that I can still write this and see it, I'm going to go ahead and copy these values down real quick. For the flight rats, we had the min was 6.39, then Q1 is 6.93, 7.72, 8.72, and finally 9.79. Okay, now I have that written down. Let's go ahead and graph these two. So we're going to do a combined box plot. Go ahead and make sure I can graph each of them, so labeling it kind of odd, but that'll work. So now let's look at the flight and control group. Let's see, for the flight group, I'll go ahead and put that on the bottom. And I'll put the control group on the top. Focusing first on the control group, since it's up there, minimum 6.99. But let's first graph the median and the quartiles. So the median was 8.5-ish. So about here. And then the quartiles, 9.4. And the other quartile, 7.39. And then connect these to make a nice box. I'm going to make sure to relabel those. Alright, let's go ahead and do the same for the other one. So the median for flight is 7.72. Almost at 8. And then the... oh, I put it in the wrong color. 8.72. Almost at 9. And the Q1, 6.93. Almost at 7. Let's go ahead and label these. Alright, and what's the next step? We need to find the quartile ranges for both of them. I already went over this. I'm going to do it a little bit quickly. And it's not the largest amount of space, so let's see. It says the inner quartile range. Let me go ahead and label this for the control rats. Boxing off my work. If it starts getting messy, the best thing to do to make things neat is to box your work off. And then I'll go ahead and create a box for the other work on the side. Not the best. Okay, and this is for the flight rats. So the control group, IQR, take the quartiles and subtract them. So 9.4 minus 7.39, that gives you 2.01. And then for the upper fence and the lower fence, 7.3, 0.39 minus 1.5 times your quartile, your IQR. That'll be 4.38. For the lower fence, oh, sorry, labeled that wrong. That's the lower fence, and that's the upper fence. That's going to be 9.4 plus the 1.5 times your IQR, and that'll give you 12.42. Now for the flight rats. Finding the IQR, you're going to go ahead and take the subtraction. So that will be 8.72 minus 6.93, which gives us 1.79. Now for the lower fence and the upper fence. Lower fence is 6.93 minus 1.5 times 1.79, which gives us 4.25. And then the upper fence is 8.72 plus 1.5 times the 1.79, which equals 11.41. So also, if you are ever running out of room on an exam or something and things are getting crunched, it is good to box things off to make things a little more separated from other items. Okay, so upper fence and lower fence. Let's go ahead and label those. For the control group, it's 4.38. So I'm going to be really rough drawing there. 4.38. And then 12.42, so up around here, 12.42. Labeling them because they're very, very approximate. And then the other group, 4.25. And then 11.41. Okay, so we need to graph the items that are falling in between those two. So let's see, what's above 4.38 for my rats? It's 6.99. So almost at 7. And then what's below the 12? Oh, it's my max value, which is 9.94. Oops, that's almost at 10. Okay, there we go. We can draw ahead my whiskers. Now let's go ahead and find the lowest value that is above 4.25 for the flight rats. And that would be the 6.39. So once again, being very approximate with my graph. And then we need to find the largest value that is below my upper fence, which would be 9.79. Which is a little less there. Alrighty, there we go. Ooh, that used a lot of room. So what am I asked to do? I'm trying to see if it looks like the spaceflight affected the rat's blood cell mass. And it does. It has shifted downwards. These are the rats that did not go into space, and these are the rats that did. So we'd say yes. It appears that the spaceflight has reduced the blood cell mass of the rats, since the median for the flight group is less than the median for the control group. So I'd say yes, it appears that the spaceflight has reduced the red blood cell mass of the rats, because the median is lower. I'm going to go ahead and abbreviate here because I'm running out of room. Flight rats is lower than the control rats. And boxing my answer. Woo, did not have enough room on that one. Should have made everything else smaller. Alrighty, so that is it for this section. Please email me if you have any questions.